On polar coordinates. Here we're going to learn about polar coordinates, which are different than Cartesian coordinates, which is just another way of saying how can we locate points in the coordinate plane. So we're going to look at how to draw them, where to locate them, and then we're going to look at when polar coordinates coincide with each other, when two different coordinates will actually occupy the same space, and then finally we're going to calculate the distance between two sets of polar coordinates. And this actually connects with something that we've seen already with triangle trigonometry. So the first thing to look at is, well, what are Cartesian coordinates? Well, we start at the origin, and then from the origin we say, okay, how far left or right? That's our x-coordinate. And then how far up or down from there? That's our y-coordinate. And so how far over and how far up, that gives us x, y. That gives us our location. Well, polar coordinate says, well, why do we have to stay going only up, down, or left and right? Why don't we just go from the origin straight to that point? So we do. And that is what we call r. And then, well, just that isn't enough because we could be going that distance over here, over here, over here. So what we also have is we have the angle. What is the angle that we're heading at as we go to that point? So we have r, that is the distance from the origin to the point, and then theta, that is the angle from the positive x-axis, or the polar axis as they call it. Now oftentimes with polar coordinates you will see the angle and the r value interchanged. It doesn't really matter as much because usually you're able to tell what the angle is. So certain sources will put the r value first, other sources will put the theta first. That's not as important as changing the x and y values. So let's plot them. Now this is what a polar grid looks like. So you see all our angles are laid out, and then we have these concentric circles. So this one is 1 unit away from the origin, this is 2 units away, and then this is 3 units away. Now when we plot, we first identify the angle. It's actually kind of backwards. We actually read the angle value first. And we say, all right, well, we're going to focus on this angle right here, 60 degrees. And then we say, all right, how far away? So we're going to say 1, 2, 3. So there is our point. There is our coordinate. On a 60-degree angle from the polar axis, 3 units away. So that's how we draw it. Let's do another one. 210, negative 1. Now this often gets people is how you can have a negative 1 value. Well, let's first identify the angle. The angle that we're looking at is 210. So right here. Now if it were 1, it'd be right here. If it were 2, it'd be right here. If it were 3, it'd be right here. But it's negative 1. What that means is it's going in the opposite direction. So actually, it's going to end up right there. So instead of pointing towards 210, it's pointing in the opposite direction away from 210. So that's what it means to have a negative r value. You identify the angle, but you count off the distance going the opposite way. Let's try another one. Negative 3, negative 270. Now we've seen negative angles before. So we start from 0, but now we're going to count down. So down to here, this would be negative 90, this would be negative 180, this would be negative 270 right here. However, our r value is negative 3, so that means we're actually going to be counting in the opposite direction. So there is our coordinate. All right, now let's do this without a grid. 2, 30 degrees. All right, well, 30 degrees is roughly that. And if I create concentric circles, I'll let that be 1 and let that be 2. So my point would be right there. at 30 degrees, 2 units away. Here, 360 degrees, -3. Now if we think about this, wait a minute, 360 degrees, that's a full circle. That would turn us right back to here. So this is the angle we're talking about. However, since it's a negative, we're not going to be looking in this direction. We're actually going to be looking in this direction. We're going to be looking backwards. So 1, 2, 3. And so the point is actually going to be sitting on the negative x-axis. Now, if you find it helpful, you can draw in the circles for this. I chose to not do it at first because it turns out that this didn't end up out in space, but rather it ended up on one of our axes. 5 pi over 6, 1/2. Let's see. 5 pi over 6. Well, 5 pi over 6 is roughly 150 degrees, so that's almost 180. So that's out here. 5 pi over 6. Now here our R value is 1/2. Now we've already seen a negative R value, so if this R value is 1, then our point is going to be halfway along here. So it's going to be right there. It's going to be halfway between the origin and this first circle. All right, -2 pi. Well, pi is right here. It's this angle. However, the R value is -2. That means instead of looking this way, we're actually going to look 2 units out this way. So if I draw my circles, 1, 2, I'm going to be looking this way, and so my point is going to end up right there. Okay, now if you've been looking through some of those examples, you'll see why did we use negative angles or negative R values. Well, the idea is that different points in polar coordinates can often lay on the same spot. So that's what this question focuses on. Here we have the point 2, 110 degrees. And the question is, which of these 6 coincide with that? So first, let's draw a quick sketch of what this would look like. 110 degrees would be off this way. And I have a radius of an R value of 2. That means my point is here. So I have a point that's in the second quadrant. So we want to look at these and see which ones of those do the same. So -2, -70 degrees. So -70 degrees would be down here. However, if I want -2, that's going in the opposite direction. So that means this point coincides with that. It's in the second quadrant, and 110 degrees and -70 degrees are actually opposite each other. So that means this point would work. So this one works. And since I have -70 right here, I can go ahead and do this one over here. What if I have 2, 70? Well, that means that I would actually go 2 in that direction. So here is 2, -70. Here is -2, -70. Now this point is down in the fourth quadrant, so this one does not work. What about this one? -2, 110. So here is 110. However, The r value is negative 2. That means it's going to be going in the opposite direction of 110. So negative 2, excuse me, 110. So that point is in the fourth quadrant, so that does not coincide. Next one, negative 2, negative 250. Well, if we have a negative, this would be negative 90 down here, negative 180. This would be negative 270, so if we pull it back 20 degrees, this is negative 250 degrees. Now, which way are we going? We're going negative 2. So that means we're going 2 units in the opposite direction. So here, this is negative 2, negative 250 degrees. So here we're ending up in the fourth quadrant. So this does not coincide. And then finally, we have 70 degrees. Now 70 degrees is right here. Now in one case, the r value is 2. That means we're going 2 units in that direction of the angle. That means we're going out here. Well, that's in the first quadrant. That doesn't coincide with this one. So we'll nix that. The other one, negative 2, 70, that's going in the opposite direction. That's going down this way. So 2, 70 degrees is here. Negative 2, 70 degrees is there. But that point is in the third quadrant. So that point doesn't coincide either. So this point coincides with that. And that's the only one of these that does. Sometimes there are more that will do that. Sometimes only one of your options will coincide. But the idea is that you have to graph them and see, all right, do they fall in the same quadrant? Do they fall in that same location? Now, what some people choose to do is to plot all the points on one set of polar axes and then see which ones work. You can do that. I chose to draw them out separately. It's up to you which way you want to do it. All right. 3, 150. We want to state all the polar coordinates that coincide with it with angles from negative 360 to positive 360. Okay. So here's what we're doing. First, let's plot this. 150 degrees is over here. And we have an r value of 3. So 1, 2, 3. So what we're looking at is we want to ask the question, how many different polar coordinates can we come up with that give us this coordinate? And we're allowed any angle between negative and positive 360. So let's start with just the positive angles. All right, so if I start here at 0, I'm not pointing at it. And if I keep going, I'm still not pointing at it. Up, here we go, I'm pointing at it. Now if I do that, I have the angle 150. So I already have this coordinate. So I haven't added anything new yet. But let's keep going. Go past 150 to 180. I'm still not pointing at it. Keep going down to 270. Keep going to 360. I'm not pointing at it. However, remember when we talked about when the r value was negative? That means we can be pointing in one direction, but we can back up. So what if our angle was pointed this way? We could have an r value of negative 3 if our angle was down here. So the question is, what is this angle down here, where if we went backwards, we would hit this point? Well, let's see. This is 30 degrees away from 180, and so this would have to be 30 degrees from 360. So that means 330 degrees. So this point will coincide with that, because if we choose 330 degrees, but we go backwards from there, we'll hit that point. And if we keep going to 360, that's all we can do. Now, let's also take the same approach with the negative angles. If I start here and go down from 0, what would this angle be in negatives? Well, I would go down 30 degrees. So negative 30 degrees, that hits that angle. Now, would I be pointing at that point? No, I would have to go backwards 3 spaces. So my R value would be negative 3. Let's keep going. Negative 90? Nope. Negative 180? Nope. What if I have this angle right here? Now again, I'm going backwards. So how many degrees do I go from 0 backwards? Well, I'm 30 degrees past negative 180. So my angle is negative 210 degrees. And since I'm pointing at it, my R value would be positive 3. Now if I keep going, I'm not pointing at the point, and I'm not pointing backwards at it either. So these are my 4 answers. Basically, there's going to be one value with a positive R value and one value with a negative between 0 and 360, and one value with a positive R value and one value with a negative R value between 0 and negative 360. So for a problem like this, there will be 4 points that coincide with that. And technically, you can debate whether to count that or not, since it's already given to you. All right, last thing. We're going to try and find the straight line distance between 2 points. Now again, in polar, everything is measured from the origin. So here's R1, here's R2, here's our 2 angles. We want to find this distance. Now if you notice, this distance, along with the R values, makes a triangle. Now, if we have 2 points, we know the R values, and we know the angles, which means we can subtract them and know the difference between them. And what this gives us is this gives us a triangle with 2 sides and an angle between them. Back when we were solving triangles, we would use law of cosines. And if you look at this formula is very, very close to the law of cosines formula. So we're going to apply that. So here are our 2 coordinates. So to use our formula, we'll say that this is R1 and that this is theta 1. This is R2 and this is theta 2. So we have the square root of R1 squared, so 2 squared, plus R2 squared, that's 5 squared, minus 2 times R1 times R2 times cosine of 10 degrees minus 130 degrees. Now, even though we're going to end up calculating this on the calculator, let's simplify this to make it easier to punch in. So this is 4 plus 25 minus 20 cosine of negative 120 degrees. And let's just put these 2 together. So that's square root of 29 minus 20 cosine negative 120. So if I reach for my calculator, again, need to be sure that I'm in degree mode for this. Square root of 29 minus 20 cosine negative 120 degrees. And we get 6.25 units. And that is the straight line distance between those two points. Let's try one more of these. Here we have these 2 coordinates. This is going to be R1. This is going to be theta 1, this is r2, and this is theta 2. So our distance will be r1 squared plus r2 squared minus 2 times r1 times r2 times cosine of theta 1 negative 35 degrees minus negative 65 degrees. So 6 squared is 36, 8 squared is 64. 6 times 8 is 48. 48 times 2 is 96 cosine. Negative 35 minus a negative 65 means we're going to add 65, positive. So that means we are left with positive 30 degrees inside of cosine. So 100 minus 96 cosine of 30. So on the calculator, square root of 100 minus 96 cosine of 30, and we get 4.11 units. And again, this is just a take on the law of cosines. If you'll notice, there's some structural similarity that you see if you look back at that formula. All right, so take some time, practice the worksheet problems, come back, and we will see how you did.